Hey, welcome back, guys, and we are starting section 3 in part 3. And in this section, we're going to be learning a little bit more about loops in Python and some other keywords that we've come across, but they're going to give us just a little bit more pointers on how to use those keywords, when do you use them, and things of that nature. So the learning objectives for this section are that after this section, you will understand when the break command is needed to break out of loops. And we've come across the break command in the past. You will be able to use the continue command to move to the next iteration, and you'll understand how nested loops work. So again, we've come across the break command when we're using if statements, when we were first introduced to loops in Python, particularly the while loop. So they're just going to tell us a little bit more about this command in particular. All right, the break command. You've already come across the break command. It can be used to stop the execution of a loop immediately. A typical example of where it is used is a situation where the program asks the user for input and the execution ends only when a specific input is received. The same functionality can be achieved without the break command using a suitable condition. The programs below both ask the user to type in numbers and calculate the sum of the numbers until the user types in -1. Okay, so this is the first version. Here we have a variable called sum, which is assigned the integer value of 0. And we have a while loop, a while true loop. So basically this command will always run. This loop will always run until something tells Python to switch this value from true to false, or if we use the break command to kick ourselves out of the loop. So here we have while true. We have a variable called number, which stores an integer value that we prompt the user for. And we have a conditional here that checks if number is equal to -1, break. Otherwise, do some compound addition, right? Do sum is equal to sum plus number. This is what this statement here is saying. It's just a shorthand way of doing that. We've come across this again in previous videos and in previous readings. And then when we break out of this loop, we print the final sum. So sum is acting as a helper variable to keep track of all the numbers that we're going to come across, and then adding them up, storing that to sum, and then at the end when we break out of the loop, print what the sum is. Now this is the second version that doesn't use the break command. So we have two helper variables. Here we have sum, which is again assigned the integer value of 0, and we have number, which is also assigned the integer value 0. And then we have a loop that uses a condition that is directly tied to one of our helper variables. So we say here, well, number does not equal -1. And then we prompt the user to overwrite, I should say, what the current value for number is. So we ask the user to input a number. If they input -1, then that's going to be our break condition. Now we have here another check. If number does not equal -1, then we want to do the compound addition again. And the loop is going to go over it again. And at any point, should we enter -1 to number, then the condition is going to, because this loop will always run, the first thing it's going to do is always check if number is equal to -1, right? And then we're going to prompt the user to type in a new number. So at any point where number is reassigned to -1, then we break out of the loop. And then at the end here, we do the same thing. We print the total sum that we have from doing a compound addition inside our while loop. So both programs print out the exact same thing with the same inputs. For example, please type in a number, -1 to exit. We type in 2. We pass in 4. We pass in 5. We pass in 3. And then we finally pass in -1. And the program finally prints out that the sum is 14. So it adds 2 to 4, which gives us 6. 6 plus 5 is 11. 11 plus 3 is 14. So the programs are functionally practically identical. However, the first method is often easier, as the condition number equals -1 appears only once, and the variable number doesn't have to be initialized outside of the loop. So as you can see, this is, I mean, it's just almost the same amount of lines of code, but this might just be a little bit easier to follow because we're not constantly having to have this check written multiple times in our program. As you can see here, this second version, we're checking if number does not equal -1 here, and we're also checking it here. Right? Where in this instance, we're only checking it once, and if it does, and if number does equal -1, then we tell Python to get out of this while loop. The break command and a suitable condition can also be used together in a while loop. For example, the following loop is repeated as long as the sum of the numbers is at most 100, but it also stops if the user types in the number -1. Again, we have our integer variable here, a variable here called sum, which stores the integer value of 0. And then we have here a while loop, which is initialized by this condition, which checks this condition if sum is less than or equal to 100. And then we have another variable here called number, which stores an integer that we that we prompt the user for. We have a conditional check here. If number is equal to -1, then break, otherwise exit out of this loop. Otherwise, do some compound addition and add number to our current sum. So this loop will break in one of two instances. The first instance is if number is -1, right? We input -1 for number, or we add up so many numbers to the point where sum exceeds 100. And so this is how the program is going to run. And these are both instances of what could cause Python to exit this loop. So in this instance is when we enter -1 for number, and in this instance is if sum exceeds 100. So in this first example, we first put in 15, then we put in 8, then we put in 21, and then we finally put in -1. And then Python prints out at the end, the sum is 44, right? 15 plus 8 plus 21 is 44. Now in this example, we don't put in negative at any point to break out of the loop. We're just going to keep adding numbers, right? We're going to keep putting in positive numbers until eventually sum is going to equal over 100, and that's going to kick us out of the loop. So we enter 15, we enter 8, we enter 21, we enter 45, 17, and then eventually this is all going to tally up to 106. So again, when the loop runs again, it's going to check, hey, is sum less than or equal to 100? No. The current value of sum is 106, so we don't execute anything inside the while loop, and we go down here to printing the sum. So this is what's happening here. In the first example, the execution of the loop stops because the user types in the number -1. In the second example, it stops because the sum of the numbers exceeds 100. As always in programming, there are many ways to reach the same functionality, right? And I've said this a bunch of times, and I think I might have said it in one of the other previous videos. Programming is very open-ended. You can achieve the exact same results using different programming languages, right? If you can write out all the constraints of your program, what the expected outputs are, how it should handle different inputs, and things like that, you can go ahead and write a program that does that in Python, in TypeScript, in Go, in C++, et cetera, right? It's like, I don't know if you guys have ever heard this term, there's a million ways to skin a cat, or 100 ways to skin a cat, and that's exactly what programming is. Like, this is just 100 ways you can achieve the exact same results. The following program is functionality identical to the above. We have a variable here called sum, stores an integer value of 0. Then we have a while true loop. We prompt the user to input a number. Then we check if number is equal to -1, then exit the loop. Otherwise, do some compound addition to tally up sum. And then we check again if sum is greater than 100, break. So it's doing the exact same thing as here, right? We've just moved this check of whether sum exceeds 100 to being inside of the loop. And we still keep this conditional check for whether number is equal to -1 to also kick us out of the loop. And we're still doing our compound addition here. So again, but in this instance, as you can see, right, in this example, we only use the break command once. But here, we do it twice, right? We break out of the loop if number is equal to -1, and we break out of the loop if sum is greater than 100. All right, again, we've come across the break command a bunch. I think by now, I think we should be pretty comfortable, or I should say familiar with it. But if you're still confused, please feel free to leave it in the comments below what you're still confused about, and I can make an additional video talking a little bit further about the break command, when we use it, why we use it, and things of that nature. All right, let's keep going. Now we're going to learn about the continue command. Another way to change the way a loop is executed is the continue command. It causes the execution of the loop to jump straight to the beginning of the loop, where the condition of the loop is. Then the execution continues normally with checking the condition. So here we have a loop that uses the break command, and here we have a loop that uses the continue command. So Python is executing our program up until we have our conditional expression, right? If the condition is true, we want to break out of the loop, continue running other code. And if the condition is false, right, we also want to break out. So this is how we can, I'm assuming this diagram, what they meant to try to illustrate is that we're already inside of a loop and we're checking the condition, right? Or we're approaching a loop and we have this conditional statement, and if that condition is true, we want to kick ourselves out, and if the condition is false, we also want to kick out, right? Now, this could be a condition at the top. Normally, we'll see this kind of condition that kicks us out immediately out of a loop if the condition is at the loop, at the head of the loop. So, for example, here, right? If this evaluates to false, then we don't want to execute anything inside of this loop block. And this could also be the same thing if we have a conditional check inside of a loop, and if that condition is met, and then we also want to kick ourselves out of the loop and continue doing other things in our program. In this instance, in this example, we approach our conditional expression. If that condition is false, we want to exit the loop and then go do other code in our program. But if that condition is true, then we want to keep looping, right? Keep going, repeating this block of code until we get to a point where this condition is going to evaluate to false and then kick us out of the loop again. For example, the following program sums up numbers from input, but it only includes the numbers which are smaller than 10. If the number is 10 or greater, the execution jumps to the beginning of the loop and the number is not added to the sum. So we have a variable here called sum, initialized with the integer value 0. Then we check while we have this while loop, while true loop. So this will run until basically forever. So that's why we have to have break command somewhere in here to kick ourselves out of the loop. That's why sometimes I prefer using loops that check a condition, because then it almost guarantees that it's never going to be an infinite loop should that condition be met. Okay. We have a variable here called number, which stores an integer that we prompt the user for. Then we check if number is equal to -1, break out of the loop. If number is greater than or equal to 10, then we want to continue. And then we want to do some compound addition for number. Okay, so this is how the program will run given various inputs. So if we input 4, we input 7, we input 99, we input 5, and then -1 is going to kick us out of the loop, right? This condition, right? This check right here is going to kick us out of the loop. But the sum is equal to 16. So what gives? So remember, in the body of our loop, we check if number is greater than or equal to 10, we don't want to do anything. Basically, what this is telling Python is, hey, go back up to the top, prompt the user for another number, check if the number is equal to -1. If it is, break us out of the loop. Come back here, check again if the number is greater than or equal to 10. If it is, circle back, right? We only want to pay attention to numbers that are less than 10. So when we enter 4, then is number greater than or equal to 10? No. So this is not going to force us to restart our loop. It's going to do compound addition and tack that onto our sum. So now sum is 4. Then again, we prompt the user for another number. They input 7. 7 is not -1, so we don't break out of the loop. And 7 is not greater than or equal to 10. So we don't force ourselves to restart the loop again. So we add 7 to 4, and sum becomes 11. Then we enter 99, right? 99 is not equal to -1, so we don't break out of the loop. And 99 is greater than or equal to 10, so we're telling Python, hey, go back to the top of the loop, because we don't want to add 99 to our sum. Then we enter 5. We check, is 5 equal to -1? It's not, so we don't break out of the loop. And we check if 5 is greater than or equal to 10. It's not, so we add 5 to 11 and we get to 16. And then we finally enter -1. We check, is -1 equal to -1? It is, and so we're breaking out of our loop. Awesome. So hopefully this made a little bit of sense. We use the continue keep command to, inside of loops, to tell Python, hey, go back and restart this loop, right? So we can usually use this with a condition if we want to avoid doing certain things. In this example, we want to avoid adding any number that's greater than or equal to 10 to our sum. So we use the continue keyword to tell Python, hey, go back to the top of the loop here. All right, nested loops. Just like if statements, loops can also be placed inside of other loops. For example, the following program uses a loop to ask the user to input numbers. It then uses another loop inside the first one to print a countdown from the given number down to 1. We have a while true loop. We prompt the user for a number. Then we check if number is greater than or equal to -1. If it is, break. Is equal to -1, not greater than or equal to. If number is equal to -1, break out of the loop. Otherwise, we want to continue down here and check that while number is greater than 0, print that number, and then decrement number by 1. So here's what the program is going to run like. We prompt the user to input a number, they input 4, then the program prints 4, 3, 2, 1, right? And then prompt the user again to enter another number. Then we print 3, 2, 1. We prompt the user to enter another number, they enter 6, print 6, 5, 4, 3, 2, 1. And then if we plug in if we type in -1, we break out of the loop and our program stops running. When there are nested loops, break and continue commands only affect the innermost loop which they are a part of. The previous example could also be written like this. While true, number is equal to an integer that we prompt the user for, then we check if number is equal to -1, break. Then we have another while true loop nested inside our outermost while true loop. And we check if number is less than or equal to 0, break. Otherwise, print that number and then decrement that number by -1. Here, this break command only stops the innermost loop. So in this instance, we're not going to break entirely out of this whole loop here. We're just going to tell, this break command is telling Python, hey, get out of this innermost loop and then run this outermost loop again until we get to an instance where number is -1, and then we break out of this outermost loop, and now our program stops entirely, which is used. So here, the ladder break command only stops the innermost loop, which is used to print the numbers. All right. So again, this break command will stop us from doing the rest of this stuff, but it won't stop us from doing this, right? It's still Python and the program is still going to prompt us. In fact, let me go ahead and copy this and go to our Python playground, so you can see this in action. Let's run this. So if I type in 5, for example, it types in 5, 4, 3, 2, 1. But if I type in 0, you can see it's still asking us to type in another number. If I was to enter -1, then it's going to kick us out of the loop entirely. So if I type in 5, right? 5 is not equal to -1, so we continue to our inner loop. Then we check, is 5 less than or equal to 0? No, it's not. So we don't break out of this inner loop. We print 5, then we decrement 5 by 1, and we do this over and over and over until we either reach 0 or somehow we get to a number that's less than 0. But ultimately, this will continue running until we reach until our number is less than or equal to 0, right? And then we're going to break out and go back up here, and it's going to ask us for another number again. As you can see here, if we entered 5, it prints 5, 4, 3, 2, 1, and then it asks us for another number. If we were to type in, let's run this program again, right? Type in 5, type in 3, type in 4, right? We can stay in here forever. If I type in -1, then it kicks us out. If I type in 0 from the jump, then it's just going to continuously ask us, right? Because it's going to check, is 0 equal to -1? 0 is not equal to -1, so we don't break out of this outer loop. Then it's going to check. Then we're going to go inside our nested loop. is 0 less than or equal to 0, then kick us out of here. Don't print 0. Don't decrement 0 by 1, right? Just kick us out of this innermost loop, and then add, and then it's going to prompt us again, right? Is number equal? Type in a new number, and then check if number is equal to -1, and so on and so forth. So this is sort of like a way, as you saw earlier, using the continue keyword, right? We can even do here if number is greater than or equal to 0, continue. All right. So hopefully that helps you guys understand about nested loops. If you have questions about nested loops, please feel free to ask them in the comments below, and I will make an additional video talking about this a little bit more. All right, more helper variables. There's a lot of readings here, and I've already, went through this section as well. After this reading on helper variables, the rest of the content in here is just exercises, so we should be good to go. All right, more helper variables with loops. We've already used helper variables which increase or decrease with every iteration of a loop many times before, so the following program should look quite familiar in structure. The program prints out all even numbers above 0 until it reaches a limit set by the user. So we have a variable here called limit. It stores an integer that we prompt the user for. And remember, this is what I was talking about in one of the previous videos about normally when I write variables in our solutions, I tend to write out full words like iterator or index or whatever. But if you're ever reading somebody else's code, if you go on to continue learning how to program and you come across example code, you will end up seeing a lot of helper variables and variables used for iteration being abbreviated. So for example, index is abbreviated. And this could be for one of multiple reasons. One of them could be that the naming a variable index could cause an error because in whatever programming languages that you're using, the word index could be a reserved keyword, right? It could be something that programming language itself is already has a built-in keyword that is also called index, so it might throw off your programming language. So that's why some programming languages might abbreviate index to I or to IDX, or you might see it sometimes used as an iterator if that helper variable is being used to iterate through a loop. So if you ever see I like this, it's just an abbreviation for index or iterator, depending on the context of the code, and you can pick up on that when you're reading the code base. But let's continue. Okay, the program prints out all even numbers above 0 until it reaches a limit set by the user. So we have a variable here, limit. We prompt the user for an integer. We have our index variable here that's initialized as the 0. Then we check while index is less than the limit, print the index and then increment the index by 2. So program is running, prompt the user, please type in a number. They type in 8, then it prints 0, then it prints 2, then it prints 4, and then it prints 6. The helper variable I is set to 0 before the loop, and it increases by 2 with every iteration. Using nested loops sometimes necessitates a separate helper variable for the inner loop. The program below prints out a number pyramid based on a number given by the user. Variable here called number that the user inputs. Then we have a while loop, which checks a condition. While number is greater than 0, then we have our helper variable I, set that equal to 0, and then we check while I is less than the number, print I, and then don't. So remember, we learned this from very, very early. If we want to print something in the same line, then we add this to our print function here, and it's basically telling Python, hey, chain every print here to on the same line, and then we increment I by 1, and then we print an empty line, or basically we're saying, hey, go to the next line here when we have an empty print block, print statement like this, and then we decrement number by 1. So when we run this program, we prompt the user to type in a number, they type in 5, and then Python prints out 0, 1, 2, 3, 4. Then it prints 0, 1, 2, 3, then 0, 1, 2, 0, 1, and then 0. So we get this half pyramid. In this program, the outer loop uses the helper variable number, which decreases by 1 with each iteration until it reaches 0. So number is being used here. The helper variable I is set to 0 just before the inner loop is entered each time the outer loop repeats. The inner loop uses the helper variable I, which increases by 1 with each iteration of the inner loop. The inner loop repeats until I is equal to number, and prints out each value of I on the same line, separated by a space character. When the inner loop finishes, the print command in the outer loop starts a new line. So here, right? So we're saying, hey, while number is greater than 0, we initialize this helper variable here, and then we check while that helper variable, while I is less than the current number, print all the numbers in ascending order in the same line, and then increment I by 1. So we're gonna stay here up until I is no longer less than number. So in this example, until I is no longer less than 5, and then we're gonna exit out of the loop. Then we're gonna tell Python go on to the next line, decrement number by 1, so number becomes 4. It checks 4 is still greater than 0. It is. I is reinitialized as 0. Then we check while I is less than 4, print current value of I up until it's no longer less than 4, and then get out of this inner loop. And so we do that. So 0, 1, 2, 3, 4, then 0, 1, 2, 3, then 0, 1, 2, 0, 1, and then 0. When the inner loop finishes, the print command in the outer loop starts a new line. Now remember that with each iteration of the outer loop, the value of number decreases. So the amount of times the inner loop repeats also decreases. With each repetition, the line of numbers gets shorter, and thus we get the pyramid shape. Nested loops can get confusing fast, but understanding the way they work is essential. You may well find the Python Tutor visualization tool helpful in understanding how this example works. Copy the above code into the code window of the tool and follow the information of the printout and the changing values of the helper variables as the execution progresses. So we'll do that for the sake of the video. We'll copy this code, paste it here, and then hit that visualize execution. So first step here, we enter 5, and then Python's going to tell us step by step what's going to happen. So first we do this, right? We just got prompted for the user when we plug in 5. Now Python's going to check while 5 is greater than 0, right? This is our while loop with a condition check. Let's go next. So 5 is greater than 0. Then we have our helper variable I here initialized with a value of 0. So nothing really to worry about here, right? Nothing that's going to make Python, kick us out of the code block yet. Then we go to the next one. We check. While I, right, where 0 is less than 5, then print the current value of I on the same line with a little space here on the same line, and then increment I by 1. So it's going to print 0, then 1, then 2, then 3, then 4, right? Then it's going to increment 4 to 5. It's going to check here again, right? 5 is no longer less than 5, so, right, they're equal. So it's not going to print 5 here. So again, it's just going to keep going back and forth, back and forth, back and forth. So the first time it prints 0. Then check, then comes down, prints 1, increments 1 to 2, then it's checking. 2 is less than 5. So come down here, print 2, increment 2 to 3. 3 is less than 5. Come down here, print 3, then increment 3 by 1. 3 becomes 4. 4 is less than 5. Come down here, print 4, increment 4 to 5. Then 5 is no longer less than 5. So we come down here and go on to tell Python, hey, go on to the next line here. We decrement 5 by 1, so 5 becomes 4. And you'll see this arrow go all the way back up here and check again. Okay, 4 is still greater than 0. We reinitialize I to 0, and we check, is 0 less than 4? It's going to print 0, going to increment up to 1. It's going to go back up here. Then it's going to check, is 1 less than 4? It is. Come down here, print 1, then increment to 2. Is 2 less than 4? It is. Print 2, increment to 3. And it's just going to keep doing this over and 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 over until the very last step when we get to 0. And then it's going to check, is 0 greater than 0? It's not, so nothing's going to get executed. All right. So I just kind of had to zoom past that because we're at the 30-minute mark, and now we have 5 exercises that we need to go through. So this is our first exercise in this section. I think we're going to be able to get through everything in one video. It's just going to be a lot more concise. I know our rule of thumb is to always keep our videos between 20 and 30 minutes, but I think we can get through everything in at least 40, 45-ish minutes. So let's try to take on these exercises. There's only 5 exercises that we need to do. All right, this one's called multiplication, and we're instructed to please write a program which asks the user for a positive integer number. The program then prints out a list of multiplication operations until both operands reach the number given by the user. See the examples below for details. So please type in a number, we plug in 2, then it's going to print 1 times 1 is equal to 1, 1 times 2 is equal to 2, and it's going to print 2 times 1 is equal to 2, and then 2 times 2 is equal to 4. So when both the operator and the operand reaches that limit, that's when our program stops. Same thing here, we plug in 3, right? Our operator goes up to 3, and our operand also goes up to 3. So we know we're going to have a variable here that is going to store our limit. So we're going to have a variable called limit. Prompt the user to please type in a number. Then we're going to have our index variable here. We'll use I in this instance. Set that equal to 1. As you can see from any of our examples here, they don't use zeros. So they start at 1. So we're going to set this equal to 1 off jump. Then we're going to say, while I is less than or equal to a limit, then just print I. And then we're going to increment I by 1. See what happens. So if we type in 2, for example, we get 1 and 2. All right, awesome. If we plug in 5, we get 1, 2, 3, 4, 5. All right. Now we know that we have to keep track of 2 sides here. We have to keep track of our operator and our operands. So this tells us that we're going to need a helper variable. So I'm going to call our second helper variable here j, and we're going to set that equal to 1. And then what we're going to do is we're going to say while j is also less than or equal to the limit, we're going to print j. And we're going to increment j by 1. And then now here we're going to leave I and increment I by 1. So let's run this and see what happens. If we type in 3, we get 1, 2, 3, 1, 2, 3, 1, 2, and then down here until we get to 3 on both sides. So this is a little bit harder to read, but we're gonna clean this up a little bit. So we know that, right, both values have to increment to our limit. And when we're setting up this inner loop here with our helper variable j, that's where we can take advantage of this. So I can also do here, we're going to use a f print, and I still have access to that variable I, and I still have access to the variable j. So this is going to be a little bit cleaner to see, right? So let's run this, and let's type in 3. Now you see 1 times 1, 1 times 2, 1 times 3. Now this is this print statement here. We're printing I again, and then I becomes 2, so we become 2 times 1, 2 times 2, 2 times. This is basically I times j, I times j, I times j. I increments to 2. I times j, I times j, I times j, over and over until we get to I equals 3. So we'll get rid of this line for it to be a little bit easier to see, right? So 1, 1 up to 3, then this 1, 2, 3, 2, 1, 2, 3, 3, 1, 2, 3. All right. So we need to actually just do the math here. So we'll just do I times j like that, and that should print out like this. So let's run this again with 3. 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3. Then I becomes 2, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. I becomes 3, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. And that should be it. So let's test this. And there we go. Let's take a look at the model solution. So they have a variable here called number. They have their counter, while counter is less than or equal to their number, which is the same thing that we're doing here, while I is less than or equal to the limit. Then they have their second helper variable here called counter2. Then they're checking while counter is less than or equal to that number. Then they do the same thing. They print out the multiplication with the solution in line. Then they increment their second helper variable by 1. And outside of this inner loop, they increment their first helper variable also by 1, which is what we're doing here. So that's the solution for this exercise. If you're feeling confused and just want a little bit of, if you have any questions about this, please ask in the comments below. All right, here we have another exercise called first letters of words. We're instructed to please write a program which asks the user to type in a sentence. The program then prints out the first letter of each word in the sentence, each letter on a separate line. And this is the example of the expected behavior. So prompt the user to type in a sentence. They typed in Humpty Dumpty sat on a wall, and then it prints out the first letter, capital H, right? The first letter of the first word, capital H, second letter of the second word, which is the capital D, then the lowercase s, then the lowercase o, then the lowercase a, and then the lowercase w. All right, so we know we're gonna have to prompt the user to type in a string. Please type in a sentence. And then what we're going to do is have a helper variable here, call it I, set that equal to 0. Then we're going to check while our helper variable I is less than the length of the string, then we want to print that string at I. And then I'm going to increment I by 1. Let's see what this does. We'll just do a Humpty Dumpty sat on a wall. And there we go. It just prints out this entire sentence all in this uniform, singular, vertical line like this. Okay. So the problem here is that we're printing everything, first of all, and we're also printing out these spaces. So that's one of the things we need to take a look. We need to keep in mind. So we need to have another check somewhere in here that's gonna make sure that we don't print out these spaces, and that we limit ourselves to only printing the first letter of each word. So this we're gonna keep because it's doing what we needed to do. It's printing first letters regardless, right? It's just printing every letter, but we're gonna narrow this down a little bit until it only prints out the first letter of every word. Okay, so we're gonna have another loop here. While I is less than the length of the string and the index of the string does not equal an empty space, right? Our spaces, then we're gonna increment I by 1. Furthermore, what we're gonna do is check while our helper variable I is less than the length of the string and the string at that index is an empty space. We're also going to increment here I by 1 because we're only concerned again about printing the first letter of each word. So what this is doing is first we're telling, hey, Python, print the first letter that you see. Okay. Then we're telling Python, hey, go ahead, scan this string for its length, and while the current position that we're in the string is not an empty line, increment that by 1, right? So basically, if we do encounter a letter here, skip it, right? Just go on, keep going. And then over here, so it's gonna go to the length of the sentence until it reaches an empty space. And then we're telling you, hey, don't worry about it. Also go ahead and increment that our index. So move our pointer over one more spot. And then it's gonna print that first letter it sees again, right? Because it's not gonna be an empty space. So it's gonna print D, and then it's gonna keep going until it reaches a space. It's gonna print the S. It's gonna keep going until it reaches an empty space, print that first letter, and so on and so forth. So let's run this and see what we get. Excuse me. And there we go, HDSOAW, same as what we see here. So let's test this. And there we go. Let's view our model solution. Let me close this. I'm just gonna close that. So they have a variable here, sentence, add space at the start to make handling sentences easier. We didn't need to do that, but we're doing it inside, and they did it this way. They have a helper variable here called index, which we abbreviated to I. Then they check in while index is less than the length of the sentence. If the current position is not the last position, and that is the last position, is an empty string, and so yeah, basically they're doing exactly what we're doing here, but just even in more concise nature. So print that letter, which will be that first letter of the first word, and then move our position over it. But I think this might be a little bit easier to read than this, but this is the model solution. Okay, we have another exercise here called factorial. We're instructed to please write a program which asks the user to type in an integer number. If the user types in a number equal to or below 0, the execution ends. Otherwise, the program prints out the factorial of the number. The factorial of a number, this is something that we should have learned in school, guys, in math class, from, I think, elementary, all the way up to college. You're going to be working with factorials. The factorial of a number involves multiplying the number by all the positive integers smaller than itself. In other words, it is the product of all positive integers less than or equal to the number. For example, the factorial of 5 is 1 times 2 times 3 times 4 times 5, which is 120. So this is some examples of the expected behavior. It says we prompt the user to type in a number, they type in 3, then Python calculates the factorial, and then prints that the factorial of the number 3 is 6. Prompt the user again, does the same thing. They plug in 4, the factorial of 4 is 24, they plug in -1, we exit the loop. Just another example, they type in 1, factorial of 1 is 1, type in 0, thanks and bye. So we know that we're going to have to print thanks and bye, right? So I'm just going to put that as the last thing. Thanks and bye, right? That's our sentence when we kick ourselves out of the loop. So I think in this instance, we're going to have a while true loop because we have to keep looping over and over and over again, and we're only going to be kicking ourselves out of the loop when we check the condition inside of the loop. So while true, and then here we're going to start declaring our helper variable. Factorial is equal to 1. Then we're going to have another helper. We're going to prompt the user to type in a number. Please type in a number. Then we're going to have another helper variable here called I, set that equal to 1 as well. Then we're going to check if number is less than or equal to 0, break. So this is our break condition. Otherwise, what we're going to do is just do factorial is equal to, while I is less than or equal to number, right? Because we need to do some compound mathematics here, compound multiplication to multiply that number to remember the factorial is the sum of all, the product of all positive integers less than or equal to the number. So we're checking while our index is less than or equal to number, then what we want to do is do factorial is equal to factorial times the index. And then we're going to increment our index by 1. Right, because we need to keep incrementing this so we can exit this inner loop. So we're going to increment index by 1 while doing the compound multiplication. And then here, we're going to finally print, we're going to use an F print statement here, the factorial of the number, passing the number, is factorial. Passing factorial there, and then let's run this. So use 3. The factorial of the number 3 is 6. Pass in 4. Factorial of the number 4 is 24. And if we pass in -1, it should tell us thanks and bye. There it is, thanks and bye. And in this example, we type in 1, 1 is 1, and they type in 0, and it kicks us out of the loop and prints thanks and bye. So let's test this. Yeah, this one's pretty straightforward. You can also do this. I'm pretty sure we'll learn functions in, I think, the next section. And with functions, you can also achieve this behavior using recursion. And we'll learn what recursion is in programming. I'll talk about it in a general sense, and then we'll also talk about it as it pertains to Python. So again, they do the same thing. They use a while true loop. They prompt the user for a number. They check if the number is less than or equal to 0. Break. We just did it a little bit later here, right? I think that's even a cleaner way to do it. Prompt the user for a number, and then if number is less than or equal to 0, kick us out of the loop. Otherwise, initialize our helper variables here. Right, so they have factorial, then they have their what we call our index variable, helper variable. They call it new. Well, new, again, this is one of the things you need to be careful of. Now, I'm assuming Python doesn't have a new keyword, right? A reserved keyword for the word new. So they can use it in their solution here. But I would avoid using certain variable names. Because again, if you go on to use different programming languages, you'll find that certain keywords, like new, for example, is reserved. Same thing for the actual naming variables like index, or specifically like index. It works in Python because these are not reserved keywords, but in other programming languages, it is reserved. They might be reserved keywords. Okay, so they check while new is less than or equal to number. Then they do the compound multiplication here, and then they increment their tracker by 1. Then they print out the factorial, and then outside of the loop, they print thanks and bye. So it's exactly what we did here, and down to the T. Okay, this is another exercise called flip the pairs. Please write a program which asks the user to type in a number. The program then prints out all the positive integer values from 1 up to the number. However, the order of the numbers is changed so that each pair or number is flipped. That is, 2 comes before 1, 4 comes before 3, and so forth. See the examples below for details. So we prompt the user to type in a number. They type in 5. So if we wanted to print this in incrementing order, we'll do 1, 2, 3, 4, 5. But in this instance, we're told that we want to print each subsequent pair in flipped order. So 1 will come before 2, but in this instance, we want to print 2 before 1. 3 will come before 4, but in this instance, we want to print 4 before 3, and then we print 5. Same thing with 6, right? 2, 1, 4, 3, 6, 5. Okay. So we're going to have a variable here called limit, which is going to store a user inputted integer. Please type in a number. Then we're going to have a helper variable I, set that equal to 1, because as you can see, all right, our outputs here don't start at 0. They all start at 1. Or 1 is the lowest number, to say. We're going to say, well, I is less than or equal to our limit. Okay, so we want to print the next largest number before the current number that we're at. So let's do this. Let's print I first, right? So you can see it, what I'm trying to achieve. Print I, then increment I by 1. So let's run this. 5, right? So we get 1, 2, 3, 4, 5. We want to print 2 before 1, 4 before 3, and then 5. So what we need to do here is just do a quick condition check. We're going to say if I plus 1 is still less than the size of the limit, right? Because as you can see, we never exceed this, right? We never exceed whatever our limit is. We always go up. The highest number will always be our limit. So we want to ask Python, hey, check if the number that's one number larger than our current index is still smaller than our limit. If it is, then we want to print that next largest number. So we'll print I plus 1. And then we'll come, so let's see this happening. So let's run this. We'll put in 5. As you can see now, it's printing 2, it's printing 3, it's printing 4, it's printing 5, right? So we still need to go back and tell Python to print that the current small number. So here we'll print I. So let's run this. Okay, we're getting 2, 1, 3, 2, 4, 3, 5, 4, 5. Well, what gives? Well, we need to change our incrementation here, right? Because we're incrementing by 1 when we want to print, but when we go to print over again, we don't want to print just the next number again. That's why we're getting these duplicates, right? It's duplicating 2 here, it's duplicating 3 here, it's duplicating 4, and it's duplicating 5. So it's duplicating because we're incrementing by 1 when we want to print the next biggest number, while still telling Python to print the current number, and then go back and increment by 1 again. So it's going to just keep duplicating itself. So we're just going to change from incrementing I by 1 to incrementing I by 2. Then we run this again, we press in 5. And there we go. We get 2, 1, 4, 3, 5. Let's try this with 6. We get 2, 1, 4, 3, 6, 5. And we know that we don't have to keep looping and stuff because as you can see from the example outputs, it only runs once, right? We give it a number, it does the printing, and then it doesn't ask us to enter a new number. Awesome. So let's test this, see how we do. And there we go. Let's check out the model solution. So here they have a variable called number, helper variable called index, where this stores the integer number that we prompt the user for. Then we have an index helper variable. Then we check while index plus 1 is less than or equal to the number, to our limit, print the next largest number, then print the current index, and then increment index by 2. And then if index is less than or equal to number, print index. I'm not sure what this is doing. Let's because we're still printing the current index and we're still printing the next largest number. So why would they have this at the end? Okay, so this prints out the final biggest number. Right, that's why we get the 5 here. All right, so that's what their code is doing. And this is our solution, basically virtually similar, just a little bit reordered of how things are printed. Okay, this is our last exercise in this section. It's called taking turns. It says, please write a program which asks the user to type in a number. The program then prints out the positive integers between 1 and the number itself, alternating between the two ends of the range as is in the example below. Please type in a number. Where we prompt the user for a number, they type in 5, then it prints 5, then it prints 4. It prints 1, then it prints 5, then it prints 2, then it prints 4, then it prints 3. Ugh, that looks kind of wonky. Okay, here's another example. User types in 6, it prints 1, then it prints 6, then it prints 2, then it prints 5, then it prints 3, then it prints 4. So this is a little bit harder to visualize. So let's do this. And I prepared this before starting to record the video. So imagine we have, these are, 5 will be our limit. So let me put this up here. I'll put this in red, right? This is the limit. So we want to print numbers from 1 up to the limit. But we don't want to go in incrementing order. We want to print first the first number, then go and print the highest number, right, on the opposite end, or print the limit. Then we're going to move our left-hand tracker over 1. We're going to tell it Python, hey, print this next number, and then move our right tracker over and then print this. And then come over here. Once these two overlap, just print the final number. So that's what we're doing in essence, is we're alternating, right? First print the lowest number from our limit, and then print the limit. Then increment from our lowest number up 1, print that number, decrement our highest from our limit down by 1, and then print that number. And then finally print the last value, which is when our left hand side tracker and our right hand side tracker overlap. So that's another way you can think about it. I think that for me, when I was looking at it this way, it made this a little bit easier to understand. And it might make it easier when we start writing our solution. Okay, so we're going to have a variable here called limit, which is going to store that integer value that we prompted the user for. Please type in a number. Okay, then we're going to have 2 helper variables, right? Because again, as you can see from our example here, we're going to need to keep track of our left hand side to print the lowest number, and our right hand side to print the highest number. So we're going to here have a variable called left, set that equal to 1, and then right, we're going to set that equal to the limit, right? Because our right hand side is always going to start from the limit, the highest number that we're going to be printing. Okay, then we're going to have a loop. We're going to say while left is less than or equal to the right, print left, right? And then we're going to need to here, for example, let me just, left is equal to left plus 1. So we can see what's happening here. So if we type in 5, we get 1, 2, 3, 4, 5, right? Still printing all our numbers in order, like how in most scenarios we might want to print our numbers. Then here what we're going to do is we're going to want to check if our left-hand tracker does not equal our right-hand tracker, then print right. So what we're saying here is if our red arrow doesn't equal our right arrow, right? Which is in this instance, right? There's no overlap. Print the right side. So this is what's going to get us to first print 1 and then print 5. And I'm going to run a space here and then run this again. As you can see here, we're getting 1, we're getting 5. We're getting 2, we're getting 5. Right? We're going to fix this where it keeps duplicating 5. But 1, 5, 5, 5. And as you can probably tell already here, why does it keep printing 5? Because we're not decrementing our right-hand tracker by 1. Because remember, in our diagram, this blue arrow has to move left while this right arrow has to move right. Our red arrow has to move to the right while our blue arrow has to move to the left. So they have to get to a converging point. So we need to tell Python that that's what we want to do. We want to move our right-hand side tracker down. So what we're going to do here, so here we're incrementing our left arrow by 1, and we need to decrement our right tracker by 1. So let's run this again. We'll type in 5, and there it is. We get 1, we get 5, we get 2, we get 4, we get 3, right? So when it prints 3 here, it's this scenario, right? When the two arrows converge. So regardless of what happens, we're always going to be printing our left-hand side, right? Our red arrow. So print left, then checks. This is what's checking the overlap, right? If these two numbers, our left-hand tracker and the right-hand tracker, don't overlap, print our right-hand tracker. So that's what's going to be allowing us to print our limit, print the number smallest from the limit, and so on and so forth. Then we increment left by 1, we decrement right by 1, and then we print left. So it's still gonna, essentially, it's almost like this makes our red arrow makes one extra move, while our right arrow doesn't move at all, right? In this instance, you can almost see it as it getting overshadowed by our left-hand arrow. So that's what our program is doing. So let's test this. And there we go. So let's take a look at our model solution. And they do the same thing. They have a variable here called number, right? Stores that inputted integer. They have a tracker for the left-hand arrow, like we're doing here, our red arrow, and a tracker for the right-hand side, which is our blue arrow. Then the checking while left does not equal right. We check the same thing. Well, we set it less than or equal to. Then they print the left, and then they also print the right. Then and this is what they're doing. They're doing it outside of the loop when they're checking for the overlap, or we did it inside of the loop. Right? Check for the overlap. If there's no overlap, then print the right-hand arrow, then increment our trackers. But they do it outside. So when it finally gets to this point, the converging point, right, then just print that final converging number, which will be our left-hand tracker. All right, so hopefully all this made sense. This is, I think, by far our longest video of the course so far. The material here was pretty straightforward, I think, at least in my mind. We learned about nested loops, and we also learned about the break keyword that we come across before. We also learned about a new command called the continue command, which tells Python, hey, when you see this inside of a loop, go ahead and start the loop over, right? Which can help us shape how our program is supposed to behave based on various inputs. So I figured it would probably be easier for us to do everything in just one video. It's a longer video. I didn't really want to sit here and just babble to you guys and read and then say, hey, come back to the next video to watch me do the exercises. So I will put timestamps so that you can skip to, right? If you don't want to sit and listen to me babble about and read these notes to you, the reading material here to you, right? You can just come down here and start watching me go through the exercises. Perhaps you prefer just to read on your own, but if you still prefer to have me read, then, thank you for watching the video. But yeah, solutions will be up at the time you see this video. Thank you so much for watching. If you have any questions about any of the stuff that we covered here today, if you have any questions about my solutions or anything of that nature, feel free to ask in the comments below. And I hope this last exercise made sense. Again, what I try to do before I even record videos is I go through the course material, and I just try to get an idea in my head. And when I get to a portion where I think, hey, that might be a little tricky to explain, I'm going to start doing this. I think this might be the way to go. Just create a quick diagram that we can reference when we get to that section, like what we did here in this exercise on taking turns. All right, so thank you so much for watching. In the next video, we're going to start section 4 on defining functions. And now somebody had asked me in one of the previous videos, at one point, would I recommend that people start doing programming challenges with Python, such as LeetCode or HackerRank. There's like a whole bunch of these websites out there that you can use to test your skills in whatever programming language that you are learning and want to maybe get a job in, right? So if you want to start doing LeetCode, I would say do all of part 3, all the way up to section 4 on defining functions, because a lot of the time, a lot of these challenges that you'll see on LeetCode, on HackerRank, will require you to be able to know how to work with loops, conditionals, and how to write functions. So I would say hold off until section 4, learn the material in section 4, practice the material, do the exercises in section 4, and then go try and do the easier rated exercises on LeetCode, on HackerRank, and you will see that there's actually a lot of familiarity between the exercises that we've covered so far in this course and what you might encounter on LeetCode, on HackerRank, and so on and so forth. Because those easier exercises on those websites, again, will more than likely ask you to use loops, will more than likely ask you to use functions. So we haven't learned how to write functions yet in Python, so it might be a little tricky when you're encountering it. If you're doing your own self-studying outside of the course and you've already gone to the point where you learn how to write functions, how to call functions, how to pass arguments to functions, etc., then feel free to go ahead and start those. But I would tell you to stay away from the exercises that ask you to do time complexities, right? And things of that nature. Just stick to the more logical based exercises that, given a certain input, we expect your code to produce this output, right? Here's some other sample inputs with expected outputs, so you can write those programs. So that's my advice for you guys. Go and do section 4 in part 3, learn functions, how to define functions, how to work with functions, and then go try and do those easier exercises on LeetCode and HackerRank and so on and so forth. All right, I hope you guys found some value, got some value from this video. Again, I'll try to put out timestamps to each section of the readings that we do in this video, and then when we start doing the exercises. All right, I'll see you guys in the next one.